How many pounds are in 24 ounces? Now, we know the conversion already for pounds to ounces. That's something we've already learned in class. So again, we've seen one strategy for how to do this, but we're going to go through the proportion method as well. So we do know that 1 pound is the same thing as 16 ounces. So typically with proportions, we set up the known on one side. It doesn't really matter if it's on the left or the right. Your book tends to like the left side. And then on the other side, you have your unknown setup. So we don't know how many pounds. That's going to be our X. But we do know the ounces. So when we're setting up our proportions, the easiest thing to do is to match ounces to ounces in the denominator and then pounds to pounds in the numerator. There's more than one way to set up a proportion, but this is, I think, the easiest way to do it. So one fraction or one ratio is your known information. The other one is your unknown, and then you match up your units. And then to solve, all we need to do, remember, is just cross multiply. So we're looking at 1 times 24 is equal to 16 times X. So 24 equals 16X. And then we solve for X by dividing both sides by 16. Now, 24 divided by 16, if you use your calculator, you do just get 1.5 there. Or if you change this to a mixed number and do some simplifying, you get 1.5. So the answer is 1.5 pounds in this case. All right, let's look at another example. So Bob is 176 centimeters tall. How tall is he in inches? And we're going to round to the nearest tenth. Now this one we don't know, we haven't learned yet, or you may know it, but 1 inch is about 2.54 centimeters. So you do still have to know the starting conversion here to get going. So here we'll use that 1 inch is approximately 2.54 centimeters. So again, I'm going to set up my known information on the left. So 1 inch, 2.54 centimeters. And then on the right, you set up your unknown ratio. So I know his centimeters is 176, but I do not know the inches. So I'll use X there, or any variable is fine for the inches. And then I'm going to go ahead and I'm going to cross multiply. So here I have 1 times 176, and then 2.54 multiplied by X. And a lot of this you could probably just start to do in your head, particularly that multiplication. I still like to take and, encourage you to take good notes because, later on in a couple of weeks, you may forget when you go back what you were doing when it's not as fresh in your mind. So you still want to have enough work there to follow along. And when you divide here, you get about, that's not exact, 69.291. And we're rounding to the nearest tenth, the problem said. So we're going to round 1 decimal place. That 9 is big, so it's going to push that 2 up. So X is about 69.3. And remember, we were in inches here. All right, a couple of things I want you to note. In general, if the answer is in feet, yards, cups, pints, quarts, gallons, teaspoons, tablespoons, or pounds, we typically use fractions if there's a remainder. And then if your answer is in, kilograms or milliliters, really anything in the metric system typically, or money, for instance, we typically use decimals. And we often use 1 or 2 decimal places. Now, of course, this can vary, right? So you want to always defer to whatever the homework question is asking or the exam question. If it specifies a specific form or format or how many decimal places, then you're going to defer that way. But in general, I think you'll notice, when we're talking about feet, yards, particularly cups, pints, quarts, gallon, teaspoons, tablespoons, and pounds, particularly like when we're baking and cooking, you tend to see that a lot with fractions just very naturally. The metric system, we usually prefer decimals because we can change units so quickly by moving that decimal point. And same thing with money, right? We tend to see money with decimals as well. So with money, we'll tend to round definitely to 2 decimal places because that makes the most sense. But with other forms, it could be 1 or 2. And again, just defer to your homework questions or your exam questions for how many places if it's specified. Now, your book has a nice table of approximate equivalents. I'm going to copy it here so you have it in your notes, but you can also just reference the book if you prefer to print it out or copy it later. Some of these we've already learned, a couple of them are new ones. So they're worth noting again, making a little note card maybe so that you can practice memorizing them. So one we just saw was 1 inch is equal to 2.54 centimeters. 1 foot we already know, but that is 12 inches. 1 yard, again, this one we already know was 3 feet. So again, you'll see some repeats, a couple new ones. 1 pound is 16 ounces. Let's see, 1 kilogram is 2.2 pounds. 1 tablespoon is 3 teaspoons. 1 quart is 2 pints. 1 gallon is 4 quarts. Also, 1 cup is 8 ounces. And here's a new one. 1 pint is 480 milliliters. I'm going to come back to this one in a second. 1 quart is 32 ounces. 1 quart is also 960 milliliters. And again, I'll come back to that one in a second. 1 pint is 2 cups. 1 fluid ounce is 30 milliliters. 1 teaspoon is 5 milliliters. I know this one I know just from medication, right? Anytime we're doing dosages, it's a very common one. 1 fluid ounce, you can also think of as 2 tablespoons. And just a couple things to note here with the star ones. So certain fields may use rounded measures here instead. So 1 pint, they would round to 500 milliliters, and then 1 quart would round to 1,000 milliliters. So just something to be aware of in our text. I think you'll notice that most of the time we're going to use the more exact values. 1 pint is 480 milliliters, and 1 quart is 960 milliliters. But in case you are in a field or you're in an office that is using the more rounded versions, do know that that is also considered acceptable in many fields as well, in case you come across that. All right, so let's use these and we'll do a couple examples. So I'm going to put this off camera, and at home, hopefully you have it again kind of next to you while we go through, so you have those conversions. And these are ones that you want to start memorizing as well. All right, so let's say I want to go from 23 feet to something in yards. And again, we're going to practice with the proportion method here as that strategy. But there's so many different strategies that you can use. So I know that 3 feet is 1 yard. Again, I start with my known information on one side. And then I'm going to make my unknown ratio on the other side. So I know that the feet would be 23, and I'm looking for the yards, right? Now remember, it doesn't matter if you put yards on top and feet on the bottom, as long as you do the same thing on the other side as well. So if you set yours up a little bit differently, you did 1 yard to 3 feet, that's fine. On the other side, you'd have X yards to 23 feet. And what happens is when you cross multiply, it's all going to work itself out. So as long as you're consistent, then it's perfectly fine. So here we have 3 times X. Here you have 1 times 23. So 3x equals 23. And then we divide both sides by 3. Now we're looking for yards here, which typically is left in fractions. So if you go ahead and find the improper fraction here, 3 goes into 23 7 times, which is 21. And then I have 2 left over. So this becomes 7 2/3 yards. Let's do 18 quarts to gallons. Okay. So again, it's known that 4 quarts will give you 1 gallon. So I do my known information as 1 ratio. On the other side, I'm going to plug in 18 for quarts, but I do not know the gallons. And again, just make sure you're lining up your units. So here I put quarts on top, so I'll do the same thing on the other side. And I put gallons on bottom, so I'll do the same thing on the other side. I cross multiply 1 times 18, 4 multiplied by X. So I just have 18 equals 4X. Divide both sides by 4. I can go ahead and either simplify first or change to an improper fraction first. It doesn't really matter. If I change over, 4 goes into 18 4 times, which is 16. And then I have 2 left over, and I can simplify that 2/4 into a half. So I have 4.5 gallons. Okay, I'm going to go to the next page, do a couple more. Two and 1/4 pints equals blank cups. I do know that 1 pint will give us 2 cups. So there's my known information. And over here, I have 2 and 1/4 pints and X cups. So even though I have a mixed number there, I'm not going to worry about it. I'm just going to cross multiply as usual. And then what I'll do is I'll work with that in the 1 minute here. So 1X. Now, because I'm multiplying, I do need to change this to a mixed number. So it's 2/1 times 9/4 equals X. And now you can multiply across, or you could simplify first. I can divide those each by 2. And I end up with 9/2. So changing this to a mixed number, I have 4 1/2. And again, I was looking for cups here. So don't worry so much if you have mixed numbers, if you have decimals mixed in, we're still going to use the same process. We're just going to take our time when we simplify. Let's say I have 12.5 milliliters and I'm going to teaspoons. Now I know that 5 milliliters is the same thing as 1 teaspoon. I have 12.5 milliliters, and I want to know how many teaspoons. So I'll use X there. And I'm going to cross multiply. 1 times 12.5 equals 5 times X. 12.5 equals 5X. Now you're just going to use your calculator to divide here. Again, when we're talking about milliliters, metric units, we usually stick with decimals. So I'm going to start with the decimal, and then I can change it over to a fraction after. I think that'll be easier. So 12.5 divided by 5 here gives me 2.5. So it's 2.5 or 2 1/2 teaspoons. Now, there's a little trick here. So let's say you divide, or you want to just change it to that decimal now, or that fraction now, because teaspoons is usually given in fraction form. What you can do if you have a decimal in a fraction is just clear it out. So if I need to move this one spot to the right, I do the same thing on the bottom. Take that decimal point, move it one spot to the right, and then I can fill in with any zeros. So I end up with 125 divided by 50. And then if you want, you could go ahead and do that long division. It goes in twice to get 100, and you have 25 left over. This becomes 2 25 over 50, which reduces to 2 1/2. So that's another way you can do it. This one was pretty easy because I think most people know that 0.5 is a half, so we could just change that over. But if you have that decimal mixed in and you need to get it to the fraction, this is a really nice strategy to use here to clear out those decimal points. All right, let's do one last example in this video, and then I think we'll pause this video and come back to a next video for some more problems that are a little bit more application-based. So we'll do one more here. Do a money one. If 12 eggs cost $1.49, how much do 18 eggs cost? And again, your book doesn't write this, but I'm going to make a note here that, of course, assuming the same ratio holds, right? This one's a little bit differently because, I think most of us buy our eggs at the grocery store. So it may not be the exact same ratio for a dozen of eggs versus a dozen and a half. But let's say you were going to a farm or something like that, and they were pricing them out as a per egg kind of basis. Then you can maybe assume that the ratio would be the same. So we're going to assume that it's the same ratio here. So we know that 12 eggs are $1.49. And I'm trying to figure out how much 18 eggs would be, again, assuming that the same price would hold. And we're just going to let that be X here. So X dollars. We go ahead and cross multiply. So I have $1.49 times 18. And then I have 12 times X. Using my calculator, I got 26.82. I divide both sides by 12, and I got that X was equal to 2.235. Now, we don't want to use 3 decimal places with money. That doesn't make sense. We round to 2 decimal places. So that 5 is going to go ahead and bump that 3 up. So it's going to be about $2.24 for 18 eggs. So you can see that we have a ton of applications that we can do here, or even just, different types of problems with proportions. They're really helpful, I think, because I know sometimes when I'm trying to convert, I may not know, am I supposed to multiply or am I supposed to divide there if I just have the conversion factor? So the proportions are really nice because you don't have to worry about that. We set up our known, we set up our unknown, and then we just follow the algebra. We follow the cross multiplying and the dividing by whatever's with the X, and we'll always get the right answer. And there's no question about, well, should I take that original number and multiply it? Should I be dividing it? It kind of takes that guesswork out, which is why I really like proportions.